In this video, we're going to try to cover how to know when to do what with limits. And many people like a checklist, so let's go through a checklist of things you could look for when you're trying to figure out what to do. The first thing that I would always look for is what is known as end behavior. End behavior is any time you are approaching either positive infinity or negative infinity. Remember that when you are doing end behavior, that's the whole high-low, low-high, or same-same. And those are always pretty easy, so let's always look for those three first. If we're not doing end behavior, then the next thing we always try first is plugging in. If plugging in works, great. If plugging in doesn't work, then we get to move on to something else. If we plug in and we get a number over 0, that's dealing with the picture. Remember, the picture is the 1 over x graph. If we have a positive 1, then it would look like this. And if we had a negative 1, then it would flip into the other quadrants. Now, if we plug in and we get 0 over 0, that's a L'Hopital situation. L'Hopital, derivative of the top, derivative of the bottom, plug in. If you still get 0 over 0, continue to do derivatives until you no longer get 0 over 0. Lastly, we have the trig shortcut, which is technically L'Hopital, but we recognize that pretty quickly and can use the shortcut instead of L'Hopital. Let's go through some quick examples. In example 1, the limit as x approaches 1 of x squared plus x. It's not end behavior, so we're going to try plugging in. So 1 squared plus 1 is 2. Pretty easy. In example 2, it is not end behavior. We try plugging in. We get a number over 0, so that's the picture. So coming from the right side, that would give us positive infinity. In example 3, not end behavior. When we plug in, we get 0 over 0. So this is technically a L'Hopital question, but remember, the shortcut for trig is we just take the coefficients there and we can put a 1. If it had been something like 3 sine 2x over 2 tan 4x, and remember, the shortcut works for both sine and tangent, then we could multiply on the top and get a 6, multiply on the bottom and get a 6, and we could also get a 1 in that case. In example 4, it is not end behavior. We try plugging in. We get 0 over 0. That's a L'Hopital question. So we're going to take the derivative of the top, which is 2x, derivative of the bottom, which is 1, plug in again, we get a 4. In example 5, we finally have an end behavior problem. This is a high-low, and a high-low is either positive infinity or negative infinity. Plugging in positives, we get a positive infinity. Next problem, again, end behavior. We can ignore these terms because we're only using those terms with highest degree. This is a same, so we're going to look at the coefficients, 3, 6, which reduces to 1/2. Again, end behavior. We can ignore the back piece. This is a low-high. Remember, a low-high is always 0 no matter what. In example 8, again, we have end behavior. This is a special case because we have square roots involved. Again, we can ignore the 1. We can ignore the plus x. Now on the top, we have the square root of 3 absolute value x. On the bottom, we have negative 2x. So notice this is a same. So it's either going to be a positive root 3 over negative 2 or a negative root 3 over 2. Here we have positive numbers plugging in. The top is automatically positive. Bottom, plug in, we get a negative, so we would get a negative radical 3 over 2. If this had been a negative infinity, we would have had a double negative, which would make a positive. Let's do that one more time. Example 9, again, end behavior. So on the top, we have root 7, absolute value x. On the bottom, we have a 3x. Again, same, so the coefficients, plugging in negative numbers. top is automatically positive. Bottom, plug in, we get a negative radical 7 over 3. Hope this helps figure out when to do what.